Let's look at this. The application layer is the layer which really has the message. So if I'm sending you an email, I'm saying to x@gmail.com. That is the message here. That's why I'm calling it M. What happens then is the message is sent to the transport layer, and in this layer it has a header transport, HT. So the actual message, you are now got a header attached to it at the transport layer, and then that goes to the network layer, in which another header is added, HN. The network layer then sends it down to the link layer. All of this is still software, right? And in the link layer, you add another header called HL. Now, what have you done? You've got one message with 3 headers. It gets even more exciting. If you look at what happens in the transport layer, I was going to tell you what each of these layers does. From the message, this is now called a segment of the message. When you put the message with the header of the transport layer, it's called a segment of the message segment. That then, when you add the header for the network layer, is called a datagram. Message becomes a segment of the message, becomes a datagram. The datagram, when it finally gets down to the link level, becomes the frame. And it is this frame that actually gets transported across the physical layer. So message and ultimately becoming a frame, the frame gets transported over the physical link. But this has to be there on the receiver side as well. So at the destination, it's exactly the same structure. You got the application layer, the transport layer, the network layer, the link, and the physical layer. Let's now see how the message actually moves. So I want to send you something. It goes through these 4 layers, and then something exciting happens. On the router side, I have got a part of this structure. So on the network, link, and physical side, so I don't have the application and the transport, only the network, link, and physical. On the link layer switch, I got only the link and the physical. So the link is the software, the physical is the hardware. So now what happens? I send a message, it goes down from application to physical, and then it does an amazing journey. It goes all the way up to the switch, up to the link layer of the switch. From the link layer of the switch, it starts another path all the way to the physical and to the network layer. So from application to physical, to the link, back to the physical, and back to the network layer. And then it doesn't end there. From the network layer, it comes up all the way back to the application layer. Only when this complete journey has been made does the receiver receive the message intended for it. Now, I'm not going to too many details here, but suffice it to understand that each of the participants of this journey have a role to play. Whether you're talking about the transfer of application to transport to network to link, this process is called encapsulation. You are encapsulating the message with a series of headers. On the other side, when the message finally comes from physical all the way up to application, this is called de-encapsulation. Now, why is this important? Suppose you are sending me a file, it can be just a 1 byte message. Just say 1 byte, nothing great. The 1 byte message has so many attachments to it. These are the overhead. The HT, the HN, and the HL are the overheads associated with transporting just 1 byte. Fortunately, a message can be 256 bytes, can be 1 megabyte. It depends on the standard that you use. But there are still overheads. These overheads therefore determine the speed of transmission of the actual message. How fast does the message come to the destination? We'll discuss that a little later, but as a manager, it's important for you because these are trade-offs that you're going to make. Depending on what standard you adopt, what standard your company adopts, you know how efficient the messaging system is. This is as far as the internet is concerned. Let's now talk about what's called a local area network or a campus area network. This is an image that describes this, a picture. It's a network within a bounded geographic region. For example, a network in an office building, a network in a college, a network within a hospital, a large hospital. These are examples of local area networks or campus area networks. Let's see what happens in this case. Again, you need to understand this because when you make a decision afterwards on what kind of network architecture to use, your IT department colleagues will ask you funny questions. Sir, should I buy this? Sir, should I do that? And you must be in a position to help them make those decisions. So let's look at this. If you look at a typical office setup, there are still in an office many kinds of devices. There are computers, laptops, there are mainframe systems, there are connections to the cloud, there are mobile phones, everything connected to this, right? Typically, an office area network or a campus network, etc., connects people in a limited area and has only one management body. What do I mean by this management body? It means there is a centralized IT department in the organization. It has the required software and hardware to manage the complete infrastructure. Sometimes they call it a NOC, I mean, different names for this, but it is not managed by 25 different bodies. There may be 25 people working in the IT department, but it is one department that manages the complete local area network. It makes it a little easier. Sometimes if the company is a multinational or geographically spread, so even within India, you have companies that are physically located in different cities and towns, and they may still share one local area network. End of the day, you still have one body responsible for managing this complete network. In the case of the internet, you could have any number of bodies managing the internet. Obviously, they still adhere to the standards, but different geographies, different towns, different cities, different governments manage it on their own. So let's look at some examples of where local area networks would be used. I already spoke about a hospital or a college campus or an office building. Some of it is up here, right? So when I'm looking at SOHO, SOHO stands for small office, home office. So for example, if I'm an entrepreneur, I work out of my home and maybe I've got 10 colleagues who are part of my company, I don't need a large network infrastructure. In fact, I need the bare minimum. So I will create a network infrastructure which is easy to maintain, which has the bare minimal cost and is enough for the 10 or 11 of us that are working in the company. In fact, I would do most of my infrastructure on the cloud, whether it is email infrastructure, storage infrastructure, compute infrastructure, everything can be on the cloud. That's an example of a local area network installation. Another example would be in university